Okay, in this video we will learn about torque. So T-O-R-Q-U-E is represented by tau. Okay, so what is torque? So torque is a tendency for rotation, and it is defined as the cross product of distance and force. So let's see what is the meaning of torque. For example, we have a screw and we have a spanner. So this screw, it is fixed in a one point, and then if you give the force at this point, so the screw will be rotated counterclockwise, right? So if you compare between, if you give a same force at this point and this point, which point will make you easier for to rotate the screw? Okay. In our experience, we know that it is better for us to give a force farther from the point. So this is a point of rotation. Of rotation. Okay, so this when you give force here, it's better, it's easier than you put force at this point. And if you give a force at the point of rotation, the screw will not rotate. So this the easiness for us to rotate the screw is represented by torque. So we want to calculate how much torque if we give a force at any point. So we define torque as the distance from the point of action. So if you have here so this is the vector of distance r. So the distance vector here is from the point of rotation to the point of action, and then we have force here. So the torque can be calculated by cross product, or for example here torque at point 3 is equal to distance at point 3 times force at point 3. Okay, so similar occur here for torque at point 1 is equal to torque at point 1 times force at point 1. So but if you give a force at this point, meaning that you have no this distance, because it is actually at that point, so we have 0. So that means the object will not rotate. So torque 0 means that this object will not rotate. Okay, so how do we calculate this vector product of r cross f? So we have to make sure that r cross f is in order, not this is not equal to f cross r. So the order is important. So we recall back our knowledge about the cross product. So we have, if we have a cross b, and the angle between them is theta, so we have the another vector which is out of the page is c equal to a cross b. So the magnitude of c is given by the multiplication of the magnitude a times magnitude b sine theta, or we can just ignore those modulus and the vector sign. So we can have the c, magnitude of c, the product of the vectors is equal to ab sine theta. So if we apply these rules to our torque, so we have torque equal to r cross f, then we have torque equal to rf sine theta, and then the units of the torque is force Newton. Okay, Newton meter. Sorry, this is wrong. So Newton meter. So usually even though this is meter Newton, this is also okay, but usually we put the capital letter in front. So the normal nomenclature for the units of the torque is Newton meter. All right, and then since this is a cross product, that means the torque is also a vector. So how do we determine the vector, the direction of the torque is by using your hands rules. So your fingers, under the four fingers of your right hands rule will give the rotation direction, and your thumb will give the um, direction of the torque. Okay, so this is also similar to determine the direction of omega vector, and also the angular velocity in the previous chapters. Okay, so let's look how do we apply this knowledge in the examples. Okay, so you are given these four cases. So for example, here this is the axis of rotation, and this is the point of action where you give a force. So calculate this torque. So you calculate T equal to, okay, so first you have to determine the vector of R, like this. So this is your R vector, and this is your F vector. Okay, so to determine that, you can actually get similar form as like this. So you have to rearrange back the vectors here. So R, and you have F here. You put at the their bottom must be connected like this. So this must be connected to this. So you have here the angle 90 degree. So we have R, F, sine. Here this is 90 degree. So here 10 times 10, you have 100 Newton meter. And then the direction of the torque is, so this is the direction of rotation, and your torque is out of the pitch. Okay, by using your right hand rule. Okay, so number two. So let's look again. So you put the vector of distance, and this is your force. Okay. Now you put it out. So you have here R, and then you put your force like this. Okay, so this is your point of the angle that you want to define. So you have to make sure that this is correct. So this is a 30 degree, meaning that this is also 30 degree. Right. So calculate the torque is equal to RF sine. So this is 90 degree plus 30 degree. So you have 120. So 10 times sine 120 degree. So how much you get? 120. So you have 0 0.8, 0.87. Okay, so you multiply by 100, so you have 87 nanometer Newton meter. And then what's the direction of rotation? So here is, if you give force here, of course it will rotate like this, and then the top is also out of the page. Okay, and then in the next example, so you have top just to the middle of the structure, and then you have F here. Okay, so we put it outside. This is our R. Okay, and then this is your tail of your vector. So this it should be like here. So this is F. Okay. Okay, so the angle between R and F is in this direction. Okay, and then you have here, this is a 30 degree, and then this is 270, I think, if I'm not wrong. Okay, right. Okay, so the torque is also equal to, sorry, RF sine 270 plus 30 is 300. So how much you have? So 10 times 10 sine 300 is a minus 0.86, so this is minus 87 meter. So you have here minus. So what does it mean by minus? Okay, so if you rotate this structure downward, so the rotation would be like this, right? So if you do rotation like this, and then you use your right hand rules, you have the torque is into the page. Okay, so this into the page is represented by this negative. All right, it's represented by that negative. Okay, and last, so we have negative direction into the page, and lastly we have here our torque equal to r f sine theta. Okay, so from here you don't have r, you don't have your r vector is 0, and it has no magnitude. So you have 0 here, and you have 10. So so you don't have any value here. So 0 might times by anything, we have 0. That means the torque is 0. That means the structure will not rotate. Okay. So help you understand how to calculate torque. So see you then.